Good morning, you guys. How are you doing? It's Miss All Day. I hope you're having a good week. I know that you've heard by now that we're going to be in the distance learning situation until the end of the year. I really appreciate your hard work and your effort. It does not go unnoticed. I really miss being in the class, though, with you guys. We're going to go ahead and get started for today, Wednesday, April the 22nd. 2020. We're going to do 9-6 dilations, and I put the textbook pages up at the top. It's pages 587 to 589. So if you open your textbook up, you see that there's a picture of someone's eyes. And this is a really good example of our concept today because I'm sure many of you have gone to the eye doctor and you've gotten your eyes dilated. So if you look at the picture on the left, the normal iris, the iris is the colored part. It doesn't change, or doesn't appear to change, we'll say. It's the pupil that changes. In the first picture, the pupil is like really, really small. The iris is about 12 millimeters in diameter, and the diameter of the pupil is only like 2 millimeters. And then in the one on the right-hand side, this is when it's in dim light. That's why whenever you get your eyes dilated, you notice they turn the lights off. Okay. You're in a dimmer light because your eyes are dilated and they're open up more. So the pupil for the eye that's been dilated is about 8 millimeters. So it has been dilated. Now, dilated basically means that you're going to change the size. It's either going to get smaller or it's going to get larger. All right, and so what we're going to learn about in the dilation is we're going to use scale factor. Now, scale factor, when you multiply something by scale factor, you're either making it larger or you're making it smaller. So you're either doing a larger representation of a figure or a smaller representation of a figure, but you're still copying the original figure. All right, so I'm going to explain some terminology here. We already went over the first one. Dilate is to change in size, and how we're going to use scale factor. All right, so let's start out with a definition of dilation. Dilation, with a center of dilation. Remember how when we were doing, rotations, we were rotating about the origin? Kind of the same thing here. You're going to be dilating about a point. So if you look at this picture on the right-hand side, the point that they're dilating about is point C. Now, C and C prime are the same thing in this picture. The original, the pre-image, is the triangle PQR. The copy, or the image, is triangle P prime, Q prime, R prime. Okay, so it got bigger. So the dilation was by a scale factor of a whole number or a number that was bigger than 1. All right, a dilation has a center of dilation. We call it C. Okay, and it has a scale factor, and the scale factor is referred to as N. Okay, so N is going to represent our scale factor. Now, this right here, I'm going to expand it a little bit. This is what your problem may look like when you get started. So if you're going to dilate, they will pretty much say that you're going to dilate by using some kind of scale factor. You know, they could use 1/2 there. They could use 2 there. Depends on what their scale factor is. About point C. And then they'll tell you what they're dilating. So in this situation, I would say that I was going to dilate triangle PQR, and it would result in triangle P prime, Q prime, R prime. So it's going to be very similar to what we've been doing, except we're going to focus on scale factor here. All right, the next thing is the definition for scale factor. So the scale factor is a ratio of the length of the image to the pre-image, with the image length always in the numerator. Now I want to make sure you understand what this means. The image length I'll do this in purple. You're going to do the image, whatever length it is, over the pre-image. So the original piece is in the denominator, and the copy, which is the image, is in the numerator. That's very important to know. I'm going to leave it right there in case you need to look back at that. Now, think about dilation. It's not going to preserve distance or length, is it? But it is still going to preserve angle measures. That's the only thing that gets preserved is the angle measures. All right. Definition of dilation. Dilation is an enlargement if the scale factor is greater than 1. So I'm going to say if n is greater than 1, it's an enlargement. Or it's a reduction if the scale factor n is between 0 and 1. So I'm going to say n has to be greater than 0, but less than 1. So it has to be in between 0 and 1. You're not going to multiply by a negative scale factor. And you're not going to multiply by a 0 scale factor. That means nothing was done. All right, so let's look at these two examples. This first one is an enlargement. It's about the center A. So if I was going to describe this, I would say this is a dilation, a scale factor of 2. It's about the point A. And what am I dilating? I'm dilating A, B, C, D. And what is my ending result? It is A prime, B prime, C prime, D prime. Now, as we're looking at this picture, this is on page 588 if you're looking at it in your textbook. This is the pre-image. Always know what the pre-image is. The pre-image is the original. It's the one that doesn't have the prime tick mark. It doesn't have this little accent mark right there. It doesn't have that accent mark. Okay, so you can tell that you're going from small to large, right? Now, remember how you get the enlargement scale factor. How you get the enlargement scale factor is you're going to take the image length. So I'm going to do C prime, D prime. The length of C prime to D prime is 4. You're going to put the image length over the original pre-image length. So I'm going to put that over CD. CD is 2. Now, what is 4 divided by 2? 2. That's where they came up with the scale factor. So think about it. If it's getting larger, it would make sense that it's a whole number or any number bigger than 1. Let's go look at the reduction. All right. This is a dilation of 1/4 about point C. What am I dilating? I'm dilating E, F, G, H. It's a quadrilateral. What is my end result? E prime, F prime, G prime, H prime. Now, how did I get the scale factor? All right, now remember back what we just said. We're going to do the image over the pre-image. So look at it and figure out which is the original. It's the big one, right? The small one is the image. So we're going to do E prime, H prime, that's the copy, over the original, which is EH. That's the pre-image. So E prime, H prime is 2, and EH is 8. And when you reduce it, you get 1/4. Well, think about it. This was a reduction. It would make sense if it is a reduction for your scale factor to be a fraction. It gets smaller. All right, let's go ahead and start with part 1, finding the scale factor. So they gave us the format, okay, that what I was just doing. I'm dilating by a scale factor about point X. What am I dilating? Triangle XTR. And what is my end result? triangle x prime, t prime, r prime. Now they want to know, is this an enlargement or a reduction? And then what's the scale factor? All right, so the first thing we're going to do is we're going to figure out the scale factor. So we're going to do the image, which is the copy. It's in light blue. It has the primes in it, over the pre-image, which is the original. I'm just going to put pre here. All right, so you find a side that has a length. Well, I see that xt. Okay, that's the pre-image, so that's going to go in my denominator. And then 4 plus 8 is going to be x prime, t prime. X prime, t prime. All right, so I'm going to have a 4 in my denominator, and I'm going to have an 8 plus 4. I'm just going to go ahead and put, instead of putting 8 plus 4, I'm just going to put 12. All right, so we know that 12 over 4 is 3. That's going to be our scale factor. We've done this before. So is it an enlargement or a reduction? Right, it's an enlargement with scale factor of 3. Now, in your textbook, it gives you multiple choice. So the correct answer in your textbook, if you're looking at it, would be B. Enlargement n equals 3. Now, before we go on to the got it problem that you're required to upload, I want to refresh with you the distance formula, because you're going to need to know this distance formula. So distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So you're going to subtract your x values and square it, subtract your y values and square it, add it together, and then do the square root of it. All right, so when you go to the next page, in the book, you're still on page 588, okay? But if you're taking notes, it's the next page. This is your first got it problem, okay? So it says, is the dilation using the scale factor n, we don't know what it is, about the origin, O, of JKLM equal to J prime, K prime, L prime, M prime? Is it an enlargement or a reduction? And what is the scale factor n of the dilation? All right, so we're doing the same thing we just did. All right, so what we're going to do is we're going to try to find the length. I'm going to do JK. You could do any one you want, but I'm going to do JK. And I'm going to tell you why. Because if you wanted to use Pythagorean theorem, you could. Right? I could do 2 squared plus 6 squared, and it will give me whatever I need. So if you want to do Pythagorean theorem, you can do it. I'm going to use the distance formula since that's what I just went over. So let's look at our points here. I'm going to find my point for J, and it is 0, 2. And I'm going to find my point for K, and that is 6, 0. So I'm going to see what the distance is of JK. So JK equals the square root of, now, let me circle the x's, and we're going to do it an easy way. What is 0 minus 6? Negative 6, right? Squared plus. So we just subtracted our x values, and I'm getting ready to square them. All right, let's look at our y values. What is 2 minus 0? That's 2. So that's 2 squared. All right, 6 squared is 36. And 2 squared is 4. So the length of JK is the square root of 40. All right. Now let's go find J prime, K prime. All right. So I'm going to erase these points just for the fact of getting them out of my way. All right. J prime is 0, 1. And K prime is 3, 0. All right. So I'm going to circle my x values, and we're going to subtract them. So 0 minus 3 is negative 3. And let's go ahead and do negative 3 squared, 9. All right, now let's do our y's. 1 minus 0 is 1, and 1 squared is 1. So the length of j prime k prime is the square root of 10. Okay, now we've gotten the information that we need. Now remember, when you're doing a scale factor, you're doing the image over the preimage. So I'm going to do the image. Remember, that is my copy. So that's going to be j prime k prime over my preimage. That's the original. That's going to be jk. So j prime k prime is the square root of 10. And jk, just kidding, right? I'm not though, is the square root of 40. All right, so do it like this. Put 10 over 40 all underneath a radical. So you can reduce it like this, the square root of 1/4. All right, now to figure out what n is, you've got to know what number times itself is going to give you 1/4. Think about it. 1/2 times 1/2 is 1/4. So the square root of 1/4 is 1/2. All right, so our answer, the scale factor is 1/2, or you could say n equals 1/2 if you wanted to. And was it an enlargement or was it a reduction? It was a reduction. And if you're not sure, do you have a fraction right there that's in between 0 and 1? Then it's a reduction. And if that doesn't sink in, then look at the picture. The original was a long line. The copy was a short one. So it was a reduction. All right, great. Now we're going to move on to problem number 2. If you look at the bottom of page 588, I have kind of condensed what they wrote about finding a dilation image. So I'm just going to go over that real quick. And I had a typo. I fixed it. It is right here. It is the word my, if you would change it to by. My bad. In your textbook, all dilations of figures in a coordinate plane will have the origin as the center of dilation. So you can find the dilation image of a point, P, with the coordinates x, y, by multiplying the coordinates of P by the scale factor n. And this is what the rule looks like. If I am dilating by using a certain scale factor, and I am dilating this point, x, y, I will take those 2 points, x, y, and I will multiply them by the scale factor n to get my new point. All right, so this is going to be really easy. Now, go to page 589, and you're going to find, mine says example 3, yours says problem 2, but they're the same problem. All right, so what we're going to do here is, they already have it graphed in your book. So if you just want to watch while I do this one, you can. But in order to do the example 4, you're going to have it graphed. So you might as well graph it with me. So we're going to graph P is 2, negative 1. Z, this is where I'm getting my points from, negative 2, 1. C. And then G is 0, negative 2. G. All right, now I'm going to connect my dots. This is the triangle that they already showed you in the book. Okay. It says, what are the coordinates of the vertices of the dilation by a scale factor of 2? Now, they didn't put, if you notice, they didn't put this part. They didn't put a parentheses, comma, O for origin, because it's on a graph. You kind of know that if it's on a graph, then it's going to be about the origin. So that's why you don't see that there, because it's a graph. It's right there. So we're going to dilate using the scale factor of 2. We're going to dilate triangle PZG, and our ending result is going to be triangle P prime, Z prime, G prime. All right, so this is what we're going to do. We're going to start with the dilation of 2 for point P. I don't know why I wrote a P like that. That was kind of weird. Now, P, we have our points right up here. So we're taking 2 and -1. And our dilation scale factor is 2. So we're going to take 2 and multiply it by the 2 for the x in the coordinate right here, x coordinate, comma, and then we're going to take 2 again and multiply it by the y coordinate times -1. So we see that 2 times 2 is 4, and that 2 times -1 is -2, and this is our new point. This is P prime. All right, so let's go graph P prime. I'm going to go do it in another color though, okay? So P prime is going to be 4, -2. P prime. All right, let's go ahead and go to our next point. Let's do Z. We're going to dilate by scale factor of 2. Z. All right, so we're going to take -2 and times it by 2. I put the 2 first last time, so I'm going to put it first this time too. You don't have to. 2 times -2. All right, and then we're 1. It's going to be 2 times 1. So 2 times -2 is -4, and 2 times 1 is 2. So our ending result is Z prime. I'm going to change my color again. I'm going to do -4, 2, and that's Z prime. All right, we have one more point to do. We're going to do the dilation by the scale factor of 2 of point G. Okay, G's coordinate for x is 0, so 2 times 0. We already know what that is, 0. And then the y coordinate is -2, so 2 times -2. Well, that's -4. So that's going to be G prime's coordinate. So 0, change my color real quick, and then go down 4, and that is G prime. All right, so I'm going to connect. Now, if you notice in the book, this ZP actually is directly on top of that. Mine's just a little off because I'm freehanding it. I can't use a ruler on the screen like you can use a ruler on your piece of paper. All right, so we enlarged it by a scale factor of 2. All right, now the next one is your got it problem number 2, located on page 589 in your textbook. This is the one you need to upload for me, the got it problem 1 at the top of the page, and now the got it number 2. We're only doing the first part. We're only doing A. All right, so I'm going to use a different color because I'm going to use that same graph that I just used. Now, it says, what are the coordinates of the vertices of a dilation by a scale factor of 1/2 to the same original triangle that we did a while ago? All right, so when we're looking at this picture, we're not looking at the work above. We are just looking at the coordinates that they gave us in the first problem. Now, in your book, if you notice, they didn't give you the coordinates. They assumed that you're going to be able to look over there at the graph and figure out the coordinates. I gave them because I wanted you to graph it first. So we are looking at these coordinates, and we're going to use them down below. All right, so we're going to do a dilation of 1/2, and we're going to do point P first again. So I'm going to do 1/2 of 2, and then 1/2 of -1. All right, 1/2 of 2 is obviously 1, and 1/2 of -1 is -1/2. So that's going to be P prime. We'll go graph them all in a minute. Let's move on to Z. We're going to take Z, and we're going to do, sorry, I didn't mean to write Z first. We're going to do a dilation by the scale factor of 1/2 of Z. So we're going to do 1/2 of -2. And you're like, I already know what that is. All right, let's go over here and write it in. That's -1. And then you're going to do 1/2 of 1. And you know what that is too. It's going to be 1/2. All right, that's going to be your Z prime. All right, now we're going to do G, scale factor. I keep wanting to put the G first. Sorry, you guys. Dilation by the scale factor 1/2 of point G is 1/2 times 0, which you already know that's 0. And then 1/2 times -2, and you know that's -1, and that is G prime. Now using the purple, I'm going to go plot those points. So we're going to do 1, -1/2, and that's P prime prime. Oh, I got to go put prime primes on these, you guys, because this is dilation, but it's a different dilation than the original. So I can't let my P prime and my P prime prime be the same thing. They have to be different points. So I went and added prime prime, just so you know that's for real. That's not like made up. All right, Z is -1 and then 1/2, and that's going to be Z prime prime. And then G is going to be 0, -1, and that's going to be G prime prime. Now, as you can tell, this is really, really small, but it was a reduction, so it should be really small. Now, in a utopian world, this line right here, all those lines on that side would have all been on top of each other. So the Z prime, P prime, and the Z prime prime, and the P prime prime, and the ZP, all those would have been on top of each other in this situation. All right, last part of this concept is basically being able to use this in a real world situation. Like when you use a microscope, you're enlarging something that's small, and on a computer, you can actually enlarge it or reduce it. All right, so let's look. This picture right here is in your textbook on page 589. It's a lot bigger than what I have here. A magnifying glass shows you an image. This image is 7 times the object's actual size. So the scale factor of the enlargement is 7. The photo shows an apple seed measuring 1.75 inches under the magnifying glass. What is the actual length of the apple seed? So think about it this way. 7 times whatever the actual length is. So I'm going to let X be whatever the actual length. You could call it the preimage if you want. You could call it the original if you want. Okay? But I know that if I multiplied 7 times the actual length, that I would get 1.75, which is the measurement of that apple seed. So what you want to do is you want to divide by 7. Feel free to get your calculator out. Type in 1.75 divided by 7, and it will give you 0.25, which is 1/4, right? Inches. Okay? That's what the original was. The original was really, really small. It was 1/4 of an inch. So, think about it. If this was an inch, it only went to here, basically. All right. Now, this last one is the got it problem number 3. This will be the last one of the got it problems that you'll be putting with your homework. And I'll put your homework problems down here in just a minute. All right, so let's do this last got it problem. The height of a document on your computer screen is 20.4 centimeters. That is the original height. When you change the zoom setting on your screen from 100% to 25%, the new image of your document is a dilation, reduction, of the previous image with the scale factor of 0.25. What is the height of the new image? So I'm going to let N represent my new image. You could have put I if you wanted to for image. You could put C for copy if you wanted to. I always like to let my variable kind of make sense in my problem. So if I took 25% and I multiplied it, that's the scale factor, times the original, I'm going to get what the new image is. So if you would multiply that out, 0.25 times 20.4, you should get 5.1 centimeters. So that would be your answer for that one. Your homework for this section, of course it says see the pacing guide. On the previous notes, the homework numbers that were given at the bottom was for last year's class. They were not for this year's class. So I went and changed all of those problems in case you thought it was for last year. All right, so this is section 9.6, and you have your got it problem 1, got your Got It problem 2A and your Got It problem 3. And then in addition to that, you're going to do on pages 590 to 591, you're going to do 1 through 4, 7, 13, and 19. So that's 10 problems. All right. I hope you guys have a great hump day, and I'll see you tomorrow. Bye. Bye. Miss y'all.